Hello everybody. Yesterday we discussed about what CPU threads and processes are and I gained a subscriber. Thank you for supporting me. Today we will discuss about what input output bound and CPU bound tasks are, and second we will discuss about what global interpreter lock is in Python. These two topics are very important for the upcoming videos where we will be discussing about what asynchronous and synchronous processes are. And in the upcoming videos, we will also discuss what multi-threading and multiprocessing is. So let's start with input, output and CPU bound tasks. To understand this, let's say you were surfing on internet and you came across a video that you found was very interesting. So you clicked on the download button in order to download this video. Now, the moment you click on this download button, then the video doesn't get downloaded at that moment, right? If that video is of big size, then it will take some time. It's not like you clicked on the button and it immediately got downloaded in your system. It will take some time depending on how big your video is. So the limiting factor here is external. It's not dependent on your CPU speed. It is dependent on how fast the server is serving or how fast is your Wi-Fi connection. It's not dependent on your own system. It's not dependent on the speed of the CPU. The only thing that you can do is wait. And it's not you who is waiting. In fact, your CPU in this case is also waiting for this video to get downloaded. CPU is not doing anything here. So such tasks where limiting factor is external and CPU has nothing to do with it, those tasks are called input output bound tasks. Now you will wonder what CPU bound tasks are. So those tasks that require your CPU to work hard. Everything is dependent on CPU. The limiting factor here is the CPU, how fast your CPU is working. If it's fast enough, then the process will complete faster. But if your CPU is slow, then the process will take time. So the limiting factor here is your own CPU. All the hard work is being done by CPU. One example could be that the video you have downloaded, maybe you want to do certain kind of processing on it, or maybe you want to do certain kind of analysis on it. So these are CPU heavy tasks. Your CPU is doing all the hard work behind the scenes, right? So such tasks are CPU bound tasks where the limiting factor is your own CPU and CPU is doing all the heavy lifting behind the scenes. Other example could be, let's say you have certain data and you want to do certain kind of data analysis. So that is also dependent on your CPU. I hope the difference between input, output and CPU bound tasks is clear. Now let's move to the next topic, that is what global interpreter lock is in Python. To explain this topic, I want to give a small disclaimer, and that is I will explain you what an interpreter is. I will not dive deep into it, but I want you to know the high level overview of how everything works whenever you write a Python code, so that you actually understand that not only what an interpreter is, but why Python blocks it, or maybe why Python locks it, right? So to understand that, let's just first understand what an interpreter is. So global interpreter lock or GIL in Python. So whenever you write a Python code, let's say you wrote def add, this is the name of the function. Don't worry if you don't understand Python. I am not kind of hard coding here. It's beginner friendly. In fact, I will explain you what this code is doing. It just, and then we write return x plus y, and then I'm calling this function for 2 and 3, right? So what I'm doing, that is I'm defining a function whose name is add, that takes two parameter x and y, and it returns x plus y whenever this function is called, right? And in Python, to call a function, you simply write its name, and within the parenthesis you pass the parameters. So this will return me 5, right? So this is Python code. Now by simply looking at this code, anybody who understands Python will be able to understand that what this code is doing, right? So this, whatever I have wrote here, this is human readable, right? I can understand it, and anybody who understands Python can understand this. Even if you don't know Python language, then even if I just give you a basic idea of what this is doing, if I give you a similar code, you will be able to decode it, right? So this is what human readable language is. We are able to understand what is written here. But if I talk about CPU, CPU doesn't understand what D is, what 2 is, what 3 is. The only thing that CPU understands is 0101, 0000. This is how it speaks, right? So it only understands two things, 0 and 1. And the language that it speaks is like 010001, dun 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 dun. Okay, so it doesn't understand this. It doesn't understand what D is, what 2 is, what 3 is. The only thing it understands is the language of 0 and 1. Now how do you reach from here to here? Because ultimately you want this calculation, right? It's not like you wrote this text and then behind the scene there is somebody sitting who is doing everything, all the calculations, and then on the screen you see the output. Behind the scenes, all the heavy lifting is being done, and we want that our CPU should be able to understand what it needs to do in order to get the final output, right? So we will understand how we can reach from this stage to this stage, and that is where interpreter comes into the picture. Interpreter, right? So let's understand. Now whenever you write your Python code and when you execute it, then what happens, that your Python code gets converted into Python bytecode by your interpreter. Okay, so now let's say this is your interpreter. What it has done, that it took the Python code as input and it converted it into Python bytecode. Okay, this is your interpreter. You must have noticed that whenever you run a Python file, there is one folder that gets created automatically, right? The PyCache folder. And within this PyCache folder, if you opened it, there are files with extension .pyc. So this is nothing but your Python bytecode. These .pyc files contains your Python bytecode. Okay, so whenever you run your script, your Python code gets converted into Python bytecode. That is done by your interpreter, and that gets stored in your .pyc file, which is inside PyCache folder. Now there is another component within interpreter that is called Python virtual machine. What it does, that it understands Python bytecode. Okay, it's like a translator who understands Python bytecode, but it works in a certain manner that it doesn't completely translates it, it goes line by line. So let's say this is your Python bytecode, which is nothing but a set of instructions written, which is equivalent to your Python code but converted into a language that your Python virtual machine understands. So it goes line by line. Let's say it read first line, and what it does that whatever instruction is written in this first line, it will call the equivalent C function. Now you will wonder that from where this C function came. So whenever you download Python 5, whenever you download Python program, then C, it's basically supported by C Python. So for every function that you write, for every functionality, whatever code you write in Python, everything has C function equivalent. Okay, functions written in C language, that does equivalent to what you are doing in your Python code. Okay, and this function is compiled at the time you download it. By that I mean, let's say you downloaded Python, then at that time all the functionalities of Python also got downloaded, that are nothing but C functions. Functions written in C language. Just like you have Python language, there is C language, and those functions are already compiled. By compiled I mean that those codes are already translated into machine code, a language that CPU understands. Okay, so let's say this is Python def, name of the function, and then whatever code you have written. Then if there was something that could convert it into machine code, then this machine code is actually what your CPU understands. Okay, so when I say that these C functions downloaded at the time you downloaded Python, these C functions are already compiled, means they are already converted into a language that CPU understands. Okay, so what this PVM does, that it goes line by line, it sees that if what this instruction is telling me to do, and it calls the respective C function, which is already compiled, already converted into a language that your CPU understands. And then once CPU has understood, when CPU has got the instructions that what it has to do, it will execute that task. So that is how this entire process is. So high level overview would be that your interpreter does all the translations. Okay, though I have told you that it has component Python virtual machine which is doing the heavy lifting behind the scenes, but at a high level overview you can think of that interpreter is taking in the Python language, interpreter is taking the Python language, and it's returning final output. Okay, now this interpreter in Python, this interpreter is locked. Now you will ask that what does this mean? What does locking of interpreter means? This means that when you are processing a Python file in this interpreter, at that time in that thread you can't execute another Python file. Now mind you that there is a difference here. Let's say this is your CPU, this is your core 1, this is your core 2. If you are not clear with what cores are, I will recommend you to watch my video that I uploaded on this channel related on thread pools and CPUs. So this is coming from there. So let's say these are your cores. So if your Python process is running in one core, then inside one thread this interpreter is locked, and until this execution is complete, this can't be transferred to another thread. It has to be complete, then only that lock will unlock and this interpreter will be free, and then another thread can use it. This is with respect to one single core. If there is another Python process that is happening in another core, then that will not be bothered by it. Okay, so this lock is only in a thread. You have to keep this in mind. This is so important because when I will be explaining you what multi-threading and multiprocessing is, this will play a very important role there. So again, just to clarify that interpreter is whatever I explained you above. Interpreter lock is global interpreter lock is that in a thread, if a Python program is running, then that interpreter can't be used by any other thread within a single core until that execution is complete. That execution has to be completed for another thread to use that interpreter, for another thread to get executed. Okay, so finally the summary is that this lock locks your interpreter. This is your interpreter. It will lock it. That means any other thread will not be able to use it until the execution in one thread is done. This is what global interpreter lock is. I hope it is clear. If you still have any kind of doubts, do tell me in the comment section. I will help you in the best possible manner. In the upcoming videos, we will be discussing what multi-threading, multiprocessing, asynchronous, synchronous processes are. So stay tuned.